Welcome to Learnpedia, the ultimate JEE and NEET prep tool that is currently being used by over 20,000 aspirants. Let's see if you can answer this actual JEE question. If you think you got the answer, then post it in the comment section below. To understand the concept behind this question, watch the video that follows.
So now we have studied today about the kinetic energy of rotation and the moment of inertia and radius of gyration. Now the kinetic energy of the rotating body we wrote as half of m1 r1 square plus m2 r2 square, so on so forth, mn rn square into omega square, which we can also write it as half of I into omega square, where I is equal to m1 r1 square plus m2 r2 square, so on so forth, mn rn square. If a particle of same mass is placed at distance r, then I is equal to m into r square. This formula, if we can say all masses are same, if m1 is equal to m2 is equal to m3 and so on so forth m, then moment of inertia we can write as m into r1 square plus r2 square, so on so forth, rn square. This r1 square plus r2 square, so on so forth, rn square in the bracket, we can replace this with an alphabet called capital K square. So I is equal to mk square, where k is called the radius of gyration. It is the perpendicular distance from the axis of rotation where the total mass of the body is supposed to be concentrated, or it is the perpendicular distance from the center of mass to the axis of rotation. K can be written as under root of I by m. K we can define as the radius of gyration. It is the perpendicular distance from the center of mass of the body to the axis of rotation. If a mass m is placed at a distance of k, then it will have the same moment of inertia as that of the rigid body. That's what it means. So suppose if I take a mass m and place it at a distance k from the axis of rotation, then whatever the moment of inertia that particle has, it will be same as the moment of inertia of the body. Let us see now angular momentum of particle describing circular motion. Now suppose this is a particle which is moving in an anti-clockwise circular motion like this. From the axis of rotation, the body is revolving in anti-clockwise rotation. The distance of the particle is nothing but the radius vector r cap. Now the momentum of the particle, since it has a tangential velocity here, is p cap. Then for anti-clockwise rotation, L vector is equal to, we know, r vector cross p vector. P vector is along the tangent. Magnitude of L vector will be equal to r p sine theta. If theta is equal to 90 degrees as in this figure, p is tangent, r is the radius, angle theta is 90. So magnitude of angular momentum will be r into p, where p is m into v. V is the tangential velocity. We can also write as in terms of angular velocity omega as v is equal to r omega. Then we can write this one as r into m into v or r into m into r omega. Angular momentum can be written as m r square omega. Since we have only one particle here, mass of the particle is m, so mr square omega. Mr square is nothing but the moment of inertia of the body or of the particle, so it can also be written as L is equal to I omega. So in analogous, linear momentum is mass into velocity, v is the linear velocity, and angular momentum is I into omega, omega is the angular velocity. In linear direction or translatory motion, linear velocity is v, in rotatory motion, angular velocity is omega. Mass is the measure of inertia in the translatory system. Then here in rotatory system, I is the measure of inertia, or it is called moment of inertia. So angular moment of the particle describing circular motion, L is equal to I omega.
Hey there, hope you understood the concept. Here's the answer to the question that was asked in the beginning. Found this video useful? Hit the like and share buttons to enjoy more such videos. LearnPedia's JEE and NEET prep tools contain over 4,000 videos and over 20,000 questions. You can access them online through our website or offline through an SD card or a pen drive. To buy now, visit www.learnpedia.in. You can also try a free demo of the product before buying.